Hello and welcome. Today I'd like to start a new project having to do with this company called Numenta. Uh, and they are working on some interesting things. It says here that they can enable 10 to 100 times performance improvements in deep learning. And I was watching a very interesting episode with their founder and CEO on ML Street Talk, which I think his name is Jeff Hawkins, and I highly recommend that. In fact, let's run over to YouTube and ML Street Talk. And Numenta. Jeff. I think it's Jeff Hawkins here. Yeah, this one, the Thousand Brains Theory. I suggest you take a look at that. It's certainly worth seeing. But the question is this really true? Can we enable much faster performance? And so I started taking a look at some of their stuff out on GitHub, and they have 46 repositories out here, and it's kind of difficult to know what to do with this stuff. You start looking through it, and there's an awful lot of it. And so I went to their YouTube channel. They have a YouTube channel. They actually have two YouTube channels. They have HTM School, which is hierarchical temporal memory, and they say that's for technical people. And then they have Numenta, which is more of a marketing site or marketing channel. And I started watching some of the videos, and they're very confused and they're confusing, and they seem to make the assumption that people have been watching them for a decade, and in my case, it's simply not true. This is really the first time that I've looked into them to any depth. Excuse me. And so where do you start with this software? Well, there's something called nupic. And this is their platform for intelligent computing. It's an implementation of HDM and a theory of intelligence, blah, blah, blah. And if you look at this is very old. It runs on Python 2.7. So I took a look at this and I thought, well, I don't really want to start messing around with anything that old. And I started looking, so I looked some more through their 46 repositories. I thought it was 47. Did they take one off? Anyway, there's something here called nupic.torch. And I thought, well, And that sounds newer at least. And I know that from some of the videos that I watched that they have been moving towards some different ideas having to do with GPUs. They had been complaining years ago, once again from old videos that I watched, that their tools didn't really align very well with GPUs. And when I saw this, I thought, you know, this is running on Torch, that's GPUs. So I thought this probably is new. And going in here, it doesn't really give a lot of information about what this is and should this be the one that we look at and so on and so forth. But I thought I'd install it. So how do you do that? Well, the first thing you do is fork it. You hit this over here, this fork thing, and I did that, and so I got my own copy of this. And why do you do this? Why do you bother forking it? Well, if you're going to make changes, then you should be able to save them. You can't save them directly to their fork, but you can save them here. Now I made a change. Here. Where is it? CD examples. Oh no, it's right here. I made a change in this sparse mnits.ipynb, and so now I can do a git add. What is it? Sparse. Oops. And now I do a git clone. No, not git clone, git commit. And all right, this first line here will be the message title, and if I wanted to add anything more, I could put it below here, but the title should be sufficient. And then git push. And so now, excuse me, I'm having a little bit of trouble this morning with my sinuses. So now, if I come back here and refresh this page, we should see here that all right, well, right here we can see that this change was made. Now, I apologize for the shakiness here, but that happens with notebooks. If you don't open them in Jupyter Labs or Jupyter Notebook, and just try to look at them, they tend to shake. And I don't know why that happens, but as you can see that I did push that change. All right, so let's let's see, what do you do next once you get in here and you fork it? Then you come here down to this code button and you grab this, you copy this. And I use SSH, you probably are going to use HTTPS, but I like to use SSH because I've set my account up so that I can do this, so that I don't have to use my username and password in GitHub. If you have SSH set up, then there's a public key and a private key that get used instead, and you don't have to use the password every time you push something. It's a big pain in the neck. So I use SSH, but I just do a copy here. Click on this, it says copied, and now you don't really need to use this anymore. You can, well, we are going to want to look at the instructions down here, but installation is very, very simple here. So ICD into my code directory, and I do a git clone, and I paste this in, and hit enter, and you'll see a bunch of messages scroll across your screen, and when it finishes up, you'll be able to CD into nupic.torch, like this. And if you go in here, there's an environment.yaml file. Take a quick look at that. And you'll see at the top here, there's a name, nupic.torch, and the Python version, and pip is a dependency, and here's how it's installed. It's installed using pip, so on. So what you do here is, if you're running conda, you do a conda env create, and it will install the stuff that's needed here, and I guess it runs setup.py and also creates the virtual environment. Now, once you have created the virtual environment, then you have to activate it. Conda activate nupic.torch, and you see over here right now I'm in the base. And if I do that, now I'm in nupic.torch. So from now on, anything that we do is going to be done in this virtual environment. So if we install software, this is where it's going to go. So we're going to do a pip. Now, it doesn't say to install tqdm, but if you don't, you're going to get an error when you try to run the notebook for this. So go ahead and install tqdm, and we're going to need to install Jupyter, and we're going to need to install Jupyter Lab also. So install those 3 packages. I'm not going to do it because I've already done it. And there seems to be a new version of Jupyter Lab out, which is really great. Now, once you've done this, CD into examples. So the setup is really easy to get this going. It's just a few commands. And so kudos to the folks at Numenta who did this, because it's by far the easiest setup I've seen. Anyway, once you get in here, take a look at this. You've got the 3 notebooks here. We're going to take a look at sparse mnist. And so in order to do this, from this directory, we're going to start up Jupyter Lab. And I like to put an ampersand at the end here. What that's going to do is it's going to start it up in the background. So what does that mean, to start it up in the background? That means that if I come back to the terminal, I can still run commands in here. And if I type jobs, you'll see that Jupyter Lab is running in the background, and it's job number 1. If I want to bring it forward, I can bring it to the foreground with FG. I can also, as you just saw, I type jobs to see what's running. And I can also kill this job from here, which I'm not going to do. But anyway, once you type that, you'll see up here that it starts up a new web page for you, and running on localhost 8088 and /lab, and here it is. And so what we want to do is we want to open up this little folder icon here, and we'll see down here that here's sparse mnist, and I'm going to start that up. And then I don't need this anymore, I'm going to close it. And then over here, I'm going to select the kernel. Now, you might not see the kernel in here. And so, let me go back to my browser here. I'm going to just do a history here, because I don't remember the... Alright, so here's the command that needs to get run. Run this command, ipython kernel install -- name, and then the name of the virtual environment -- user. And after you run this, and you can run it right here, because this guy is in the background, right? This guy is in the background, so the Jupyter Lab, you can run it there. And then if you come back up here and click this again, you should see nupic.torch on here, and you just select it. And what does that mean? That means that this is going to be using the virtual environment. So if I do a which Python here, you'll see that it's out here in MiniForge, env, nupic.torch, bin Python. So it's grabbing the correct, within this terminal, it knows the correct Python to use. If I do Python version, you'll see here that we're using 3.8.13. And now that we have registered or installed the kernel up here and chosen it here, we're also going to get the same, let's see, let me add a cell here and do a bang Python bang which Python, and hold the shift down and hit enter, and you'll see this is using the one in nupic.torch. And if I do a bang Python -- version 3.8.13. So this is fine. Let me see do I delete this cell now? Maybe here? Alright, so I got rid of that cell. I don't need it. So, once we get to this point, we're ready to start running this notebook. And so, the way to do this is to hold down the Shift key and hit Enter. And that will run the cell and move the pointer to the next cell. So now if I do this, it's going to install all of this stuff here. Right? And there we go. It's pretty fast. Of course, this was already done before, so everything is already satisfied. But it comes back very quickly anyway. And then here, so what did we do here? We installed Torch and Torch Vision. We installed Git, and we installed, no, we didn't install Git. We installed the Numenta GitHub. I'm sorry, we installed nupic.torch, and we did it directly from GitHub. So nupic.torch is the library that we're going to use rather than simply using Torch to build our model and then run it. And what Numenta is saying is that it's a lot faster. And all right, so what are we doing here? We're importing some libraries, and see, I changed this statement here. I was getting an error from, this is what it was. It was from tqdm, import tqdm under notebook as tqdm. And it came back with an error, and I did a Google search on the error, and it came back. I found some Chinese page that said to change it to this, from tqdm.notebook, import tqdm. So I did that. I made the change, and the error went away. So this is basic operating procedure. The environment we're operating in today, all of these libraries change, and you'll see these errors, and you have to read the output and read the error messages, and then search on them, and you will find the answer. So, so we're setting a seed here, and this is so we can get repeatable results. And we're also testing to see if there's a GPU available. So let's run this. So we're not getting a Python extension here. I suspect that's because I am running on an M1 Mac. But I got this before, and it doesn't seem to matter. I'm going to just move on. Now what are we doing here? Here we are defining some functions, and you know, this is we're defining how we're going to train this model. So, you know, we're choosing our optimizer here. We're showing the target. So in other words, this is going to go to the CPU or to the CPU or the GPU, etc. It sets our loss. and so on. And so here we can see that this is a torch.nnn module. Here's the parameter loader, the loader type, the optimizer type, the loss function to use, and so on. This all gets defined within this function. And then here's how we're going to test it. And once again, these are all the things that get defined in here. And we haven't run it yet, we've just defined it. And then we set our parameters. Let's see, let's make sure this was run. And then we set our parameters. We set the learning rate, the gamma, the momentum, the number of epochs, the first epoch batch size, the training batch size, and the testing batch size. So here it says there are two ways to create nupic.torch sparse models. You can import the models from nupic.torch.models or use PyTorch Torch Hub API. In this example, we will import the models. From nupic.torch.models, import MNIST sparse CNN. For this example, we will use the default values. All right, and then we'll print out the model here. And so here's what we're getting. We see it's setting the sparsity to 0.4, which means that the arrays that we use are not going to have more than 4%, 0.4% of its values turned on. It's going to be sparse. And it's a convolutional, two-dimensional array, and here's the kernel size is 5.5. Here's the stride for it, and all of the layers here then are going to be defined. So if we were to draw this out, we would see our input layer, and then we would see our hidden layers, and then our output. And you see we're using softmax here. We're going to determine which of the output nodes is the most likely. And now we have to load our data. And so I'm going to run this. And it happens very quickly, surprisingly quickly. And we're going to start training here. And what we could do is we could take a look at the TensorFlow notebook that they use as an example for MNIST, and we can compare how long these take. But I can tell you that this is very fast. This is surprisingly fast, how long this takes, or how long this doesn't take. Now, I'm not sure what this means here. One of the problems I find with Numenta is that they expect you to know a lot. They don't really make it easy for people who don't have a PhD in machine learning and I suspect that even for people with PhDs, if they haven't been following Numenta for a long time, they probably don't understand a lot of the language that's being used. Anyway, that happened, in my opinion, that happened pretty quickly. Let's keep going here. Now they have something called a boost strength factor, and I've never heard of this before. And we're using these percent here is what do they call this? They call this Jupyter Magic, I think. It's a different kind of mode for a notebook. So I don't really know what's happening here. I'm just going to keep on going. Now we're running tests, and we can see here that we ran a large batch size through here, or at least a larger batch size, and we came up with an accuracy of 97.74%, a very small loss. So this tells me that the training did a pretty good job, and we're going to go back and train on larger batch sizes now. And this takes a bit longer because we're going to be running, I guess, 10,000 training examples through, and we're going to do that 15 times. But I think that compared to how long it takes TensorFlow to run this same MNIST data set, this is pretty fast. Now I should skip through this, but I probably won't because I'm lazy. So this is going to take a little while. In fact, I could just pause. I could pause the recording, but I'm not going to do that because I'll probably mess it up. This really happens. Considering that I'm running this on a M1 Mac Mini, which is not a large system. It does not have a separate GPU. How should I say this? It has a GPU, but it's not a big NVIDIA monster GPU or anything like that. It's I guess it has 8 cores, which is supposedly equivalent to about a what is it, a 1660, NVIDIA 1660 or 1650 size GPU, but it's nothing like a K80 or a 3080 or something like that. It's nowhere near that in size. And we can see here that our loss is getting smaller. We went from 9,906 up to 9,914 correct. So the error is getting small, but it was pretty good to begin with. And this accuracy, this over 99% accuracy, is probably a lot better than what a human could do looking at these digits, handwritten digits. I mean, if you look at some of these, it's hard to tell if something is a 0 or a 6, for example. A lot of the times it's difficult to tell that, and this artificial intelligence is very good at guessing correctly, much better than what humans can do, which is amazing because this is a problem that recognizing handwritten digits is a problem that the post office wanted solved for many, many years, and the accuracy was not good until we started applying these machine learning methods. And of course, initially it took a long time to train these models. And of course, they didn't have this degree of accuracy even. I know that when Jan LeCun first did this, that he got very good results, but I don't think they were, I'm not sure if they were in the high 90s. I kind of doubt it. But this is an historical fact, and we could look it up. But I'm not going to do that. We should be pretty close to done here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We should have just a couple more to do here, and then we should be done. I don't know why this one went so quickly compared to this one. Kind of odd why that happens. Maybe memory pressure. Alright, so I think this is the last one. If not, it's close to the last one. Alright, and we ended up with 99.9915%, 99.15% correct. So less than 1% wrong. And here's the error, here's the loss. And you see we dropped back a little bit here on the last one here. I don't know. It starts to look like it's overfitting when we get that. But here we'll do another thing here. We're going to add some noise, and we're going to add. Well, let's get it started because it takes a while. So what we're doing here is we're adding some noise to these images here, and the noise is random. And so if you've got a white digit on a black background, handwritten, we're adding in some more white pixels that should make it more difficult to recognize the digit, and we're doing it in this order. First, we're not adding any, then we're adding 0.05%, all the way up to 0.5. Is this 50%? I'm not sure if this is 0.5% or 50% noise. Not sure. I just woke up a little while ago and my brain's not working too well, so yeah, I'm not sure. But as you can see, the more noise we add, the worse the accuracy gets. But still, 87, especially if that's 50% noise, that's a lot of noise, and we're still getting 87% correct. That's kind of amazing. And if you watch the HTM school, the hierarchical temporal memory school videos, the first few of them from Numenta, they go into a lot of detail about how robust these sparse matrices are. That if you encode using sparse matrices, you can add a lot of noise and still get good results. And I think this was very quick. I don't know if it was 100 times faster. Well, actually, I know it's not 100 times faster, but it might have been 10 times faster than or more than what we would get for a similar training session using just plain torch or using TensorFlow. And so I would encourage you, if you also want to run those other methods using just plain torch, not using nupic.torch, see what the time difference is for this. I think that would be very interesting. Yeah, so I haven't run these other notebooks yet. And it may be that some of the questions I have about this library will be answered here in these other couple of notebooks here. And I think there may be some other notebooks. No, I don't see notebooks here. These may be the only notebooks out here. Yeah, there isn't one here. And this is data. That's the MNIST data set. And we should see more data in here when we run these other notebooks. But that's it for now. I hope you enjoyed this and learned something, and I hope that more people take a look at Numenta, and I hope that Numenta takes a look at this, and maybe they'll understand that people are interested in their work, and the people who are interested are not necessarily at the level they are speaking to. I kind of get the impression that they are speaking to their own small group primarily, and that's okay if that's what they want. But if they want to reach a larger audience and have more people embrace their technology, it would be helpful to simplify some of the things that they're saying, and also take down some of those old videos that no longer apply, and give people a roadmap for learning that makes sense. But they're great people, and they're doing great work, and I applaud them. Just asking, I guess, for a little bit of help, just to make it a little easier for people who are not as enmeshed in their platforms. Anyway, thank you very much for joining me. I hope you learned something. Like and subscribe if you will, and bye-bye.